In this recording, we're going to talk about what is the population regression line, what is stochastic PRF, and what is non-stochastic PRF. So, suppose we are interested in finding out whether students score in CBSE board exams, are they sort of related with family income or not, right? So, please write suppose we are interested in finding out whether a student's family income is related to so y is the score in class 12 CBSE board exams and x is the income. X is the income, right? And what we have done is that we have divided this income variable into 10 classes. Into 10 classes. For example, 2 lakh, then 5 lakh, then 10 lakh, 20 lakh family income, annual family income, 40 lakh, 50 lakh, 1 crore, right? Like this. So I'm not going to just write those family incomes. I'm just going to write x1, x2, x3. So just imagine x1 being 2 lakh and x10 being 1 crore annual family income, 1 crore and above. Uh, So what you have is like this. So you have math scores or CBSE board exam results here, scores here, and the family income here. Hmm. Now, for X1 level of income, let us say this is 2 lakh rupees, 2 lakh and below level of income. You found out that there are few people, I mean, most of the people they are getting around out of 500, they are getting around 250 to 300 marks. So you've got 10 people and those people have got between 250 to 300 like this. So you've got the data here for x1 level of income. You've got this data out here. This x1 is beta 2 lakh and below, and this is the number of or the scores in CBSE board exams, and the mean here is this. Let's say the mean is 360 out of 400. Oh, sorry, 260 out of 400, 250 to 300. So it is 260. So this is the mean. So for each income level, there are several. There are several scores, right? For 2 lakh and below family income, these are the several scores which you have. Maybe one or two outliers might also be here, but generally people, let's say, are having this. You've surveyed the population and you've got this result. So for each income class, let's say you have surveyed 10 people, right? This is what your population is. For X2 income class, that is 5 lakh, 2 lakh to 5 lakh, there is little. Again, you've got 10 people. Again, you've got the 10 people. And now the marks are somewhat between 290 to 325, something like this. Hmm. So, and the mean for them is somewhere here, somewhere here. So what you have is basically you will be finding this out for different classes, different classes. Uh, that is, we'll be finding it out for different income classes. This data you will find out. Something like this. And for each of these income classes, you will also find out the uh, the mean also, right? That is, this mean looks way high. Hmm. It should also look like mean, right? So yeah, and then you join all of these means together for different income classes. And you join these means together. So these are the points which you are connecting the line. I mean, what are these points? These are the conditional mean of y given x. So for these are 10 people beta here. So you've got the marks for 10 people for this income class, and then you've got the mean of them. Then again, you've got 10 people here for this income class, and then you've got the mean of them. So these are the mean values of each income level. So this is the conditional mean value. Conditional mean values. So these are the mean values of the marks, uh, these circles which I have just drawn for each income level, right? In general, if you see, there is an upward trend. There's an upward trend in general. If you see generally, that is, as your income levels are increasing, there is an upward trend in the marks which people are getting. In general, that's true, right? So generally, overall upward trend in CBSE scores. One thing, right? And again, you have to look at this, since you've assumed that the data is representing the population. So the line which is connecting these conditional mean values is what is called the your population regression line, right? So since we have assumed the data representing the population, right? Population score values. population score values. The line the line connecting the conditional means is called population regression function or population regression line, right? This is what you call as population regression line, right? So it is giving you the mean value of the dependent variable, which is y, corresponding to each value of the independent variable x, right? It seems somewhat linear, so you can assume a linear population regression line. So you can assume population regression line is approximately linear out here. So this doesn't, it is not curved enough, so it's almost linear, uh, approximately linear. So you can just write this line. And since this line is about the condition, I mean, it is just connecting all the conditional means. So I can just write this as EY given XI. So that's a conditional mean. Conditional mean of these core values given what is the for a given class, right? That is equal to beta 1 plus beta 2 xi. Beta 1 plus beta 2 xi. So that's a linear line, na? Y is equal to mx plus c type. It's a linear line. So this is your intercept term. This guy is the slope term, and we call these beta 1, beta 2 as parameters or regression coefficients So, and what is this slope parameter measuring? That if xi is going to increase by 1 unit, then dependent variable is going to increase by beta 2 units. That's an idea. That is the conditional mean of y given xi is going to change by beta 2 units. That's an idea out here. So how do you write this? The rate of change. How do you interpret the slope parameter? Rate of change of conditional mean value of y per unit change in x. Per unit change in x. You with me, beta? Hmm. You with me? For per unit change in x. So let's say a unit change in x is this x is in lakhs of rupees. Huh? This x is lakhs of rupees, right? So if family's annual income, let's say it increases by 1 lakh rupee, then the conditional mean of y given xi is going to change by beta 2 units. That's an idea. So if you have, let's say, the population regression line like this, so if you estimate it and you get like this, let's say 7.4 and let's say 5xi, something like this. So how do you interpret this 5? You say that if xi is family's annual income in lakhs of rupees. So if a unit change here would be in lakhs of rupees. So if family's annual income is going to increase by 1 lakh, then then the conditional mean of y given xi is going to change by 5 units. It's going to increase by 5 units because there's a plus sign out here, right? So the CBSE score for a student in class 12 is going to increase by 5 points. Now let us say you have like this. So you have family income out here, you have CBSE scores out here. And this is what the line which is connecting all the conditional means, right? So for the family income of X1, that is, let's say 2 lakh rupees and or less, let us say the mean value score was somewhat, what, 275 or something. That's the conditional mean value score. But for any particular student, that's the mean value of those 10 individuals. Now, but for any particular student, it may not be true. Maybe one particular student would have also got 300. That is also true, right? So it may not be true. So when you write the population regression line, so you might have to add the stochastic component also. UI, that's an error which is there. Uh, so although while drawing the population regression line, what you have done is just you have taken all the conditional mean values and connected them. But it is not necessary that every student will have marks which is equal to the mean value. Someone could have more and lesser than the mean value for that particular class. That is also true, right? So you have to add this term, error term, or to this thing. So it is error term or random term, random error term, or stochastic component, right? Uh, so its value cannot be known a priori. You don't know what this error is, although here the error is 25 for this particular individual. I mean, this value cannot be known a priori. Uh, so it's a random variable. The error term is a random variable for its value. Can't be controlled a priori. You don't you can't know error beforehand. No, that's not there. So this is when you add error term to this population regression, what this population regression line itself is called the stochastic population regression line. So this is called stochastic population regression function when you add this term. Stochastic population regression. So, and this one is the noise component or the error component or stochastic component, whatever. Noise component, or you can say non-systematic component, or you can say a random component. And what about this? This is the systematic component or non-stochastic beta 1 plus beta 2. UI is stochastic. Beta 1 plus beta 2 xi is non-stochastic. And when you add stochastic component to non-stochastic, then this entire thing is called stochastic PRF. Non-stochastic component. This beta 1 plus beta 2x or you can say deterministic component or systematic component. So this you know, right? You know the different classes. You know these variables, systematic component. Uh, so, and what is the stochastic PRF is telling you? Stochastic PRF is telling you that how the individual scores are going to vary around the conditional mean values in the presence of the error term. So, how individual scores. So here these are CBSE scores. How individual scores vary around their mean values due to the presence of stochastic error term. Due to the presence of stochastic error term. Uh, and when you write this error term just as this without a stochastic term, this is called deterministic or non-stochastic PRF or non-stochastic PRF, right? So what is it that we have known here? What is it that we have learned here? That is, what do you mean by a population regression line? So that's an idea. Next time we'll talk about the stochastic component and the sample regression line, right? Thank you, Beta.